Good morning, students. Today's topic is equipotential surfaces. See, equipotential surfaces. If you see this word equipotential, equi means equal, potential surface. So you can also make its definition. Okay, what is equipotential surface? Surface is such that at each and every point potential is equal. So what is equipotential surface? An equipotential surface is a surface with a constant value of potential at all points on the surface. At all points on the surface, potential is constant. How? See one example. Suppose we have a point charge Q. What is potential due to point charge at distance r? V is equal to kq upon r. Point charge Q at distance r. At this point, potential is kq upon r. At distance r, at this point, what is potential? kq upon r. This side, kq upon r. At distance r, kq upon r. So if I draw one surface passing from such points, having equal potential is called equipotential surface. So if R is constant, potential is constant. For point charge, equipotential surfaces are concentric spherical surfaces. It is first equipotential surface. It is second equipotential surface. Third equipotential surface. Means for point charge, equipotential surfaces are concentric spherical charges having charge at center. Yes, at each and every point on equipotential surface, potential is equal. But for two different equipotential surface, potential is not same. If I have one point on this equipotential surface and one point on this equipotential surface, then potential is different. Clear? So equipotential surface is this. Now you have to remember one point about this equipotential surface. One point, and it is very clear, electric field at every point is normal to equipotential surface. See, in this figure we can also derive. Due to point charge, positive charge, electric field is radially outside. So see, I am drawing electric field. Radially outside. It is electric field. Radially outside. So see, at each and every point, this electric field is normal to surface. Electric field is normal to surface. So one important point about equipotential surface we have to remember is electric field at every point is normal to equipotential surface. Now how to prove this statement? We are taking one example. See, it is one equipotential surface. Points A and B are on equipotential surface. Let we want to bring charge Q from A to B. On equipotential surface. Then what is work? W is equal to Q delta B. Delta B means potential difference between 2 points. So it is VD minus V. Now it is equipotential surface. A and B, they are points on equipotential surface, means that potentials are equal. So potential of A and potential of B, they are equal. So VB minus VA is equal to 0. Then what is work done? 0. What is another equation of work done? Integration E dot dl. For unit positive charge. E dl cos theta is equal to 0. E, electric field, is not 0. dl, displacement, is not 0. Then what is 0? Cos theta. And cos theta is 0 when theta is equal to 90. But we know that this theta is angle between E and dl. dl is in this direction. Then E must be normal to it in this direction. As this displacement AB is in plane of equipotential equipotential surface and electric field is normal to it. Electric field is normal to it. So from this we can prove that electric field at every point is normal to equipotential surface. Is always equal to equipotential surface. Clear? One more point. For uniform electric field, equipotential surfaces are planes normal to field. See, parallel and equidistant electric field lines means uniform electric field. For this uniform electric field, equipotential surfaces are plane normal to electric field lines. Clear? For dipole, negative charge, positive charge, equipotential surfaces are like this, concentric circles. So it is one point, equipotential surface. What is equipotential surface? And one important point about this. Remember, electric field is normal to equipotential surface. Clear? Pause your video and write down in your notebooks. Good morning, students. We will continue our topic electric potential and electric field. What is difference between them? One more question based on this. Exercise 2.14. You are given two tiny small spheres. Tiny small spheres means you can consider them as point charges. Okay. Q1 1.5 microcoulomb, Q2 2.5 microcoulomb. Separated by 30 centimeter distance, means distance between them 30 centimeter, 0.3 meter. You have two questions. First, find electric potential and electric field at the midpoint. See, first of all we will draw figure. Q1 charge, Q2 charge, distance between them is R. Let O is midpoint. As it is midpoint, we say R1 is distance of midpoint from Q1 charge. And R2 is distance of Q2 charge from B. So as it is midpoint, we can say R1 is equal to R2 and is equal to half of distance between them. So R1 is equal to R2 is equal to R by 2. What is R? 0.3 meter. 0.3 divided by 2 is 0.50. So what is R1 and R2? Clear? Okay. Now at this point we have to find electric potential. See, first of all find electric potential because it is a scalar quantity and scalar quantity easy to find. So see, potential at point O, V is equal to V1 plus V2 due to Q1 and Q2. V1 means K, Q1 upon R1 plus K, Q2 upon R2. You know what is value of K? Q1 and Q2, you have to convert microcoulomb in coulomb, that is 10 to minus 6. R1 and R2 is equal to 0.15 meter. Calculate, you will get your answer. Now, we will find electric field at point O. As electric field is vector quantity, we have to write E is equal to E1 plus E2. See what is difference between scalar and vector? Scalar quantity, we can add them easily. V is equal to V1 plus V2, algebraic sum. But for vector quantity, you have to write vector relation. E is equal to E1 plus E2. And now how to write its magnitude? After direction. First of all, you have to check direction of E1 and E2. See in figure, what is direction of E1 and E2? At midpoint, Q1, positive charge. Due to positive charge, electric field is outside. Simple. Due to Q2, positive charge, electric field again out. Okay. So, as both charges are positive, both are equal charges, electric field due to them, they are in opposite direction. So from figure it is clear, E1 and E2 they are in opposite direction. Then how to write magnitude? E is equal to E1 minus E2. Why minus? Because they are in opposite direction. Now if answer of E is positive, then resultant electric field is in direction of E1. Clear? If answer is negative, then resultant electric field is in direction of E2. Calculate E and find in which direction is resultant electric field. What is question B? See, again Q1, Q2 charges, midpoint O. So this distance is 0.15 meter, it is also 0.15 meter. Now you have to find electric potential and electric field at a distance 10 centimeter. 10 centimeter means 0.1 meter on perpendicular bisector at this point. At this point, let it is named P. Okay, at point P, you have to find potential and field. See, we know what is value of Q1 and Q2. First of all, we will find distance. See, from Q1, distance of point P is R1. From Q2, distance of point P is R2. Now see, 0.15 meter, 0.15 meter, and it is 0.1 meter. So if you find this hypotenuse, this R1 and R2 will be same. So we can find them. R1 is equal to R2 is equal to 0.15 whole square plus 0.1 whole square. Its square also is 0.18 meter. Clear? So first of all, find R1 and R2. Now, as potential is scalar quantity, we will first find potential. Potential at point P. V is equal to again V1 plus V2, K Q1 upon R1 plus K Q2 upon R2. Clear? Any doubt? You can easily calculate this. Yes, convert microcoulomb in coulomb. Okay. Now, what about electric field? Electric field is vector quantity. First of all, find electric field at point P due to Q1. E1 is equal to K Q1 upon R1 square. What is equation of electric field? KQ upon R square. So it is K Q1 upon R1 square. Now at point P, what is electric field due to Q2? It is K Q2 upon R2 square. Okay, see, there is a small change, a small difference in equation of potential and field. For potential it is KQ upon R1, for field it is KQ1 upon R1 square. Clear? Any doubt? So first of all find E1 and E2. See, find each and everything step by step. So if this term is right, you will get your marks. If this term is right, you will get your marks. If this term is right, you will get your marks. So find each and everything step by step. First of all find E1, then find E2. Now as electric field is vector quantity, first of all write that vector relation. The resultant field at point P, E is equal to E1 plus E2. Now we have to check its direction. See here in figure, due to this Q1 charge, electric field at point P is on the line joining two charges outside. So it is direction of E1. Clear? Okay. Similarly, you do Q2 charge. What is electric field at point P? Again, outward, because it is positive charge. So it is E1 and it is E2. E1 and E2. Okay, they are not in same direction. They are not in opposite direction. So E1 and E2, they have some angle between them. So we have to use law of parallelogram. And to apply law of parallelogram, first of all we have to find angle between two vectors. We are assuming this angle is theta. So according to symmetry of figure, we can say this angle is also theta. Okay, so what is this total angle? 2 theta. Now see, E2, E1, if this angle is 2 theta, this angle will also become 2 theta. Then what is angle between E1 and E2? 2 theta. What is angle between E1 and E2? 2 theta. Clear? Okay. Now, how to apply law of parallelogram? We know that if R is equal to A plus B, then magnitude of R is equal to under root A square plus B square plus 2AB cos theta. Then E is equal to E1 plus E2. Magnitude of E is equal to under root E1 square plus E2 square plus 2 E1 E2 cos angle between E1 and E2 is 2 theta. Clear? Okay. Now E1 you have calculated, E2 you have calculated. Then now we have to find what is value of cos theta. Then again from figure, see, we have assumed that this is angle theta. In this right angle triangle, apply cos theta. Then cos theta is equal to adjacent side upon hypotenuse. Okay, there it is 0.1 divided by R2. R2 means 0.18. You will get 0.5556. Find value of theta 56.25. 2 theta 112.5 degree. Then cos 2 theta you will get minus 0.38. Cos 2 theta you will get minus 0.38. Okay, put value of cos 2 theta here. You will easily calculate. You will easily find what is value of E. Okay. Now what about direction of E? See, we are assuming that suppose alpha is the angle made by electric field, resultant electric field with E1. As we have already studied in 11th, law of parallelogram. So from law of parallelogram, what is angle made by resultant vector with E1? Tan alpha is equal to E2 sine angle between two vectors upon E1 plus E2 cos angle between two vectors. If you calculate this, you will get your answer. Alpha is equal to 76.8 degree. See, this angle depends on question. Here we have found angle with respect to E1. You can also find angle with respect to E2. You can also find angle with respect to positive x-axis. Okay, so as we select reference axis, your answer is also ready. Okay, here this angle alpha is with respect to E1. So it is one question based on scalar and vector quantity. Electric potential scalar quantity and electric field vector quantity. And see, from this question it is clear. Scalar quantity is easy to find. So whenever you are asked to find some questions, first of all find electric potential because it is scalar. It is easy to find. Clear? You have to calculate this whole sum. Okay, you have to calculate this whole sum. Write down in your notebook and send notes on my WhatsApp number. For other school students, for verification of your answer, send notes to your respective subject teachers. એક ઇમ્પોર્ટન્ટ મેસેજ છે સ્ટુડન્ટ્સ, આજથી 11th સાયન્સ પણ ચાલુ થઈ ગયું છે. જે રીતે 12thના ઓનલાઈન લેક્ચર્સ યુટ્યુબ પર મુકાય છે તે જ રીતે આજથી નોલેજ હાઈસ્કૂલ આણંદ દ્વારા 11thના ફિઝિક્સ, કેમિસ્ટ્રી, મેથ્સ અને બાયોલોજીના પણ ઓનલાઈન લેક્ચર્સ સ્ટાર્ટ થઈ ગયા છે. તો જે કંઈ પણ તમારી આસપાસ નોલેજના સ્ટુડન્ટ્સ હોય, અધર સ્કૂલના સ્ટુડન્ટ્સ હોય, એ આ ઓનલાઈન લેક્ચરનો લાભ લઈ શકે છે. થેન્ક યુ.